Hello there. Welcome to the fall final review. We're almost done, getting ready for that break. I'm excited, and I know you guys are too. So let's get through this, and hopefully the final will go very well for us. All right, it says, give the 5 ways to prove that triangles are congruent and the evidence needed for each. Okay, so remember S is side, and A is angle. Okay, so we have side, angle, side, 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 angle, side, angle, and angle, angle, side, and then the odd one out, HL, remember that's hypotenuse, leg. Okay, so side, angle, side. It's 2 congruent sides and the included angle have to be congruent on the 2 triangles. Okay, so included angle, that would mean like you have the side here and the side here, and the angle that's between them. So you have this one congruent and that side congruent, and the angle that is between those 2 sides. Okay, side, 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 that's just 3 congruent sides. So all the sides on the triangles are the same, then they are congruent. Okay, angle, side, angle. You have 2 angles and the included side that need to be congruent. So you have an angle and another angle, and that side between them. Those have to be congruent. Okay, angle, angle, side, that's 2 angles and the non-included side. So you have an angle here and another angle here, and this side that's not between those 2 angles. Okay, and then our last one, hypotenuse, leg. So you have, and this is only for a right triangle. Okay, so there across, that's your hypotenuse. And then it has to be either one of these other sides as the leg. Okay, and those have, the matching pieces have to be congruent on both triangles. Okay, next thing, it says 2 angles whose sum is 90 degrees are complementary. That's not how you spell that. Complementary. Okay, because remember, it's always right to give a complement. Okay, because they make a right angle. An angle that measures 120 degrees is an obtuse angle. Is greater than 90. Okay, 2 angles whose sum, whose measures have a sum of 180 are supplementary. Okay, supplementary. Opposite rays form a line. Remember, so here's one ray, and the opposite ray has to start at the same beginning point and go the other direction. Okay, so they're making a line. The intersection of 2 planes is a line. Okay, think about where the ceiling and the wall meet. So here's this, right? And then you could have a wall coming here. Okay, where these 2 are meeting is this line. Adjacent angles share a common ray and vertex. So you have an angle here. If you want one adjacent to it, they're sharing this point in the middle and also this ray in the middle. Vertical angles are congruent. Okay, and then a segment bisector divides a segment into 2 equal parts. Okay, because you have a line and then this is bisecting it, so it's making 2 equal pieces. All right. right, next thing here. It says, refer to the figure below for questions numbers 10 and 12. Find the length of UH. Okay, two easy ways you can do this. You can count, okay? But be careful. Notice you have to jump over this one in the middle to count 1, okay? So UH, so it's 1, 2, 3, 4. Or what you can do is subtract their coordinates there. So UH, so we can do -5, okay, minus -1. And we have to do the absolute value of it because we want our answer to not have any sign to it. So -5 minus -1, that's the absolute value of -4, which is just 4. All right, name a segment that is congruent to UO. Okay, by congruent, they mean the same length, so UO. So we'll see, okay, from U to O, we have 1 minus -5, so that's 6. So the length of UO is 6, so we need another segment that is also 6 in length. So let's think about it. Okay, from 1, we go 1, 2, 3, 4, 5. No, OS doesn't quite work, so we can't do that. Okay, how about H? Maybe if we go from H to one of these points here. So let's see, 1, 2, 3, 4, 5, 6. HN, that'll work. And of course, that's not the only one, but just so we understand, congruent segments have the same length. Okay, it says find point A that is 2/5 of the distance from point U to point N. Okay, so from point U to point N, first thing you gotta do is find the total length there. So from U to N, it goes from -5 all the way to +5. So 5 minus -5, that's 10. So the whole length is 10. So we take that total distance and we multiply it by that fraction. So 2/5. So that's going to be 4. So to go 2/5 of the distance, I have to move 4 units, and it's from U to N. So 1, 2, 3, 4. And I land at point H, which is at -1. So A is where point H is, -1. Okay, next thing here. It says refer to the figure at the right for questions 13 through 15. Name the intersection of line L and plane P. Okay, well, a plane and a line, they intersect at one point, and that is point D. Okay, name 4 coplanar points. So that's 4 points that are on the same plane, so A, B, C, and D, because they're all lying within this rectangle there on that flat surface. Okay, write another name for plane P. Remember, you can choose 3 of the points on the plane as long as they're not all in one line. So we could call it ABC, plane ABC, or you could do ABD, you know, any combination of those 3 points, or 4 points. You just choose 3 of them. Okay, it says in the figure at the right, WY bisects UV. So WY, this line right here, is bisecting UV. So that means UY, sorry guys, Charlotte is scratching my bag over here. Okay, so that means UY and YV, those are congruent. And then also, so it's bisecting at point Y, okay, and then UY, okay, this line here, bisects TW at point X. So TX and XW, those are congruent. So this is for each situation, find the value of X and the measure of the indicated segment. Okay, so UV, that's the whole segment here, is X plus 6, and UY, which is half of it, is X minus 1. So I'm going to take UY and multiply it by 2, because it's half of it. So 2 times X minus 1 is equal to the entire line, X plus 6. And here, I'll put some colors here. So uy and yv, okay, those two are equal to each other, and if you add them, you get uv. So that's why I'm doing 2 times the 1/2 of it. So we get 2x minus 2 is equal to x plus 6. All right, and we solve this. This 2 will go here, x will come over there. So we get x is 8. And then they want us to find the length of yv. Okay, yv is this half of the line. So we know it's going to be equal to x minus 1 because our 2 halves are equal. So you have 8 minus 1, so it's 7. Okay, now it says tx is 2x plus 1 and xw is x plus 7. Okay, tx is the whole, or I'm sorry, half. Tx is only half. And then xw is the other half. So those are equal. And then they want us to find tw, which is the whole thing. So we have 2x plus 1 is equal to x plus 7. Okay, we'll solve this for x. So minus x, we get x, and then minus 1. X is 6. So now we want tw. So basically, since they've told us that the line is being bisected, that's how we knew that tx and xw were equal. I can just plug into 1 and multiply it by 2, and I got the whole thing. So I'm going to do 2 times 6 plus 1. So 12 plus 1, that's 13. And so 13 times 2, 26. So x is 6 and tw is 26. Okay, next piece. It says wx is x plus 5 and tw is 4x plus 5. Okay, wx is half the line. Tw is the whole line. So 2 times half of it is equal to all of it. So we get 2x plus 10 is equal to 4x plus 5. Okay, take away 2x from both sides. So we'll end up with 2x over here. Okay, take away 5 from both sides. And so you get 5. Divide by 2, so you get x is 5 over 2, which is 2.5. Okay, so there's x. And then tx, we need to find tx. So tx is just half that line, and it's equivalent to wx. So I'm going to do 5 over 2 plus 5. So that's 5 over 2 plus, and now 5, I need to get that over 2 there. So I'm going to do 5 times 2 over 2. So I get 10 over 2. Okay, so 5 over 2 plus 10 over 2 is 15 over 2, also known as 7.5. All right, good. And remember, your calculator will help you take care of that stuff. Okay, so now we're on the second page here, and I'm just going to do half the review for this video, so it doesn't get too long. Okay, it says find the slope of the line parallel and perpendicular to the line passing through the given points. So remember, parallel lines have the same slope, and perpendicular have the opposite reciprocal. So this first one is going to be parallel, okay, and over here this is going to be perpendicular. Okay, so first, in order to find it, you have to find their slopes. So y2 minus y1 over x2 minus x1. So 0 minus 1 over 2 minus 4. So 0 minus 1, that's negative 1. 2 minus 4 is negative 2. So negatives cancel and you just get 1/2. So a parallel line, it would have the same slope. So parallel would be 1/2 as well. Perpendicular, it would be the opposite reciprocal, the negative reciprocal. So since this is positive, it will become negative. And then you do the reciprocal of 1/2, which would be 2. Because 2 over 1 is just 2. Okay, now the next one here. Again, y2 minus y1, so 2 minus negative 1 over x2, 4 minus x1, 2. Okay, 4 minus 2 is 2. That's the easy part. Okay, 2 minus a negative 1 is really 2 plus 1, so it's 3. So their slope is 3 over 2. So a parallel line would have a slope of 3 over 2, and a perpendicular line would be negative 2/3. Because you flip it and you put the opposite sign. All right, it says, determine if the following statements are true or false. If false, explain why. Okay, the side opposite the right angle of a triangle is called the leg. Okay, false. It is called the hypotenuse. Okay, so you have a right triangle. The side opposite right there, that's your hypotenuse. Okay, a triangle in which no two sides are congruent is called scalene. This is true. A triangle with two acute angles is called acute. That's false. Okay. Actually, all angles have to be acute if it's going to be acute. So all angles need to be acute if it's going to be called acute. Okay, because remember, you can have an obtuse triangle where you have one obtuse angle, or you can have a right triangle where you have a right angle. Okay, an equiangular triangle is defined as a triangle with three congruent sides. Okay, I'm going to put this as true, but in parentheses. Because remember, if your triangle is equiangular, then that means that it's going to be equilateral because of the hinge theorem. Equiangular. Okay, equiangular ensures that it is equilateral. So it's true because of the fact that it being equiangular means that it's also going to be equilateral. Okay, but remember, equiangular means equal angles. Okay, the sum of the measures of two remote interior angles is equal to the measure of the exterior angle. This is true. So we can draw a little triangle here. Okay, and if you extend this bottom side there, that angle right there, that's your exterior angle. And it would be equal to the sum of this angle up here plus this angle over here. Those are your two remote interior angles. So we'll call them A and B. So x is equal to A plus B. An equilateral triangle has angles that measure 60 degrees. True. Okay, because equilateral means equiangular, and 180 divided by 3 is 60. And in an isosceles triangle, the side opposite the vertex angle is the hypotenuse. Okay, that one is going to typically be false. Okay, it's called the base. All right, because we have base angles. But in the vertex angle is the one angle that's different. Because here we have an isosceles triangle. So these are congruent there. And so this angle up at the top right there, that's your vertex angle. So here is called the base. And remember, these are your base angles, and they're congruent. So this is typically false unless you have a right isosceles triangle. Because if you have a right isosceles triangle, the right angle is up here, which means that that would in fact be your hypotenuse. So it's called a base. Unless it's a right isosceles, then it is in fact the hypotenuse. Okay, a triangle with angle measures 95, 35, and 50 is an obtuse triangle. True. Okay, 95, that's greater than 90, so it's got an obtuse angle. Okay. Last few ones here. Okay. It says, use the figure at the right to answer the following. Classify triangle ABC. Okay, so triangle ABC. We see here it's got these two equal angles. So it is an isosceles triangle. Okay, and let's see. Let's figure out this angle here because we can tell if it's an obtuse isosceles or whatnot, or right isosceles or acute. So do 180 and take away 38 and 38. Okay, so 38 and 38 is 76. So we get 104. Okay, so it's actually going to be an obtuse isosceles because this angle right here is 104 degrees. All right, now it says find the measure of angle ACD. Okay, ACD. Okay, you see how I trace this corner? This is the angle we're talking about, ACD. So they want us to find that one here. Well, if we know this guy over here is 104, they're making a straight line. So 180 minus 104 is 76. And now find the measure of angle ACB. Okay, ACB is this angle right here at the base, and we already found it. It's 104. Okay. A different way to find this ACD right here, the 76-degree angle, is remember this is an exterior angle, so it's equal to the sum of these two isosceles angles there, the base angles added together. And 38 plus 38 is 76. So that's another way to do it. All right, now it says find the length of BC. Okay, BC and AC, they're congruent because this is an isosceles triangle and the sides across from the base angles are congruent. So we have 2x minus 5 is equal to x plus 3. So if you solve that, you get x is equal to 8. And now to find BC, we just plug in 8 plus 3, that's 11. Okay, last section here. It says find the measure of angle A in each of the following. Okay, main thing you got to remember is that the three angles inside a triangle always add up to 180. Okay, so we've got an isosceles triangle here, so this one's 40. That means that this one down here is also 40. So 180 minus 40 and 40 leaves you with 100, and that happens to be angle A up here. It's 100. So you really didn't have to figure out x, okay? But you can if you want, and if you plug it in, you'll get that it is 100 as well. Okay, 46 or 47. I'm just gonna work straight down here. Again, we got an isosceles triangle, so guess what? You don't have to do a lot of work again. If this is 40, this guy over here is also 40. So 180 minus 40 and 40, and it is 100. Okay, and if I wanted you to find x, well then you'd have to set 4x plus 20 is equal to 40, and then you get x. Alright, 46. We got a right triangle here, so this is 90. So right away, 180 minus 90 is 90. So these two angles here, A and C, they have to add up to 90. So 2x minus 2 plus x plus 5 equals 90. So 2x and another x, that's 3x. Negative 2 and 5, that's a positive 3. Okay, take away 3, so you get 3x is equal to 87. And you divide by 3, and so you get x is 29. And then to find the measure of angle A, okay, to find angle A, all you have to do is plug in. So 2 times 29 minus 2. 29 times 2 is 58, and 58 minus 2 is 56. Okay, last one here. Okay. Again, the three of them have to add up to 180. Okay, so I'm just going to go around here. So I have a 3x and a 2x and another x. So just add those together. 3 plus 2 is 5 plus another one. So we have 6x. Okay, and then we have a negative 17, a negative 5, and a positive 40. So just take 40 and take away 17 and take away 5, and you get 18. So we have 6x plus 18 is equal to 180. So that's just adding these three angles together, and it's got to be equal to 180 because it's the three angles inside a triangle. Okay, so now let's go on here. Take away 18 from both sides, so you get 6x is equal to 162, and divide by 6, and so you get x is 27. And then last step, to find angle A, do 3 times 27 minus 17, and you will come out with 64. Alright guys, so that's it for this video. We did about half the review or so. We've got 1, 2, 3 more pages to go. So I'll see you guys in the next video.